Hello everyone! In our last lesson, we talked about traditional methods of identifying microorganisms and gained a clear understanding of their morphology. It was really interesting. Today, we will discuss the use of matrix-assisted laser desorption ionization time-of-flight mass spectrometer, or Maldi Tof Ms, for microbial identification. Maldi Tof Ms is a type of mass spectrometer analysis technique that combines the principles of matrix-assisted laser desorption ionization, or MALDI, and time-of-flight mass spectrometer, or TOF Ms. As a biomolecular analysis technique, it can be used for rapid and accurate identification of microorganisms. This method is widely used in the fields of biology, chemistry, and medicine, and can be used to analyze and identify large molecules such as proteins, peptides, carbohydrates, and nucleic acids. As you may have noticed, Maldi Tof Ms is related to mass spectrometer technology. That's right, the working principle of Maldi Tof Ms is based on mass spectrometer technology, using organic acids or other compounds as matrices to protect the sample and promote desorption or ionization during laser irradiation. Combined with TOF mass spectrometer analysis of ion flight time, rapid identification of molecules is achieved. Compared to conventional mass spectrometer techniques, it has the advantages of being fast, highly sensitive, low cost, and easy to use. The Maldi Tof Ms technique is widely used in the biomedical field for various applications, including protein identification and analysis, analysis of biological macromolecular structures, microbial identification, drug metabolism and pharmacology studies, and analysis of small molecules in biological samples. In addition to these applications, Maldi Tof Ms is also widely used in fields such as mass spectrometer imaging, molecular imprinting, and environmental analysis. Similar to the liquid phase triple quadruple mass spectrometer we've discussed before, Maldi Tof mass spectrometer consists of three main components: ion source, analyzer, and detector, plus a computer for data analysis. First, the sample is loaded. Generally, samples are manually added by mixing the analyte and matrix solution and pipetting it directly into a stainless steel sample plate. However, some high-throughput laboratories may use an autosampler. The matrices used in Maldi Tof mass spectrometer are what sets it apart from other mass spectrometers. They are usually compounds that can absorb laser light, such as cinnapic acid or rutin. These matrices have good crystallinity, absorb laser wavelengths, and are compatible with the analyte, promoting its dissociation and ionization. The matrix also acts as a protective barrier, absorbing the laser light and transferring it to the sample molecules to prevent excessive decomposition. Whether manually or automatically added, the method for adding the analyte and matrix mixture must ensure even coverage on the sample plate and no interference between samples. The samples need to dry on the plate, typically using a nitrogen gas stream. Once the sample plate is prepared, it is loaded into the mass spectrometer's sample chamber, where matrix-assisted laser desorption ionization, or MALDI, takes place. While general mass spectrometers use electrospray ionization, Maldi Tof mass spectrometers use laser desorption, which is a technique for desorbing molecules from a solid matrix surface. In Maldi Tof mass spectrometer, the matrix absorbs the sample, and a short pulse laser irradiates the matrix analyte, converting the laser energy into thermal energy, causing an explosion that dissociates the sample molecules and sends them towards the ion source and into the mass analyzer. During ionization, the sample molecules become charged. The mass analyzer then separates them based on their mass-to-charge ratio, or MZ. In Maldi Tof, samples are separated based on their constituents by flying or drifting through a time-of-flight or drift region. Since the sample has been ionized, it can be accelerated by a high-voltage current and fly through the tube before reaching the detector. The time each molecule takes to reach the detector depends on its mass, meaning smaller molecules arrive faster than larger ones. Speaking of which, let's revisit some physics knowledge. In this scenario, charged particles are accelerated through a tube under the influence of an electric field. Therefore, let's imagine the potential energy in this case as ZeV, where Z is the charge of the sample molecule, E is the electron charge, and V is the voltage we apply to the tube. The kinetic energy of these flying particles is 1/2 mv squared, where m represents mass and v represents velocity. According to the law of conservation of energy, these two values are equal. Assuming the length of the tube is L and the flight of time is t, the particle's velocity is v equals L over t, which is distance divided by time. Now we can rewrite this equation as ZeV equals 1/2 m of L over t squared. From this equation, if we rearrange it slightly, we obtain the mass-to-charge ratio, or m over z, or m over z equals 2eV t over L squared. V is the voltage we apply, so we know its value. L is the tube length, which is fixed, and the flight time is what we analyze in this detection method. Just by analyzing these parameters, we can understand the mass-to-charge ratio of the sample molecules. When the ionized proteins collide with the detector, it reads peaks based on their time of flight and the number of simultaneous hits. This is how we analyze data to identify proteins. The detector records the number of events in a specific time frame and uses this information, along with calibration standards, to determine the sample's composition. The pattern analysis is quite complex and resembles analytical methods used in artificial intelligence work rather than those typically seen in proteomics. Maldi Tof Ms is a mass spectrometer that can be used to study the composition of any molecular component, and in recent years, it has been increasingly used in the routine healthcare checks to identify specific bacteria. So why is Maldi Tof so useful? As a mass spectrometer, it can be used to identify the composition of any molecule. Compared to current used methods, Maldi Tof is a more efficient and cost-effective approach, and it even has the potential to replace gram staining and biochemical identification. Thanks for watching.